Welcome to our second lesson in Unit 4 on writing functions. In this lesson, we are going to focus on identifying the dependent and independent variables in a function. We will be able to write an equation in function notation. There's a special notation we'll learn about. And we will be evaluating a function for different inputs. So first off, when we're writing or graphing functions and equations, we need to be able to identify which quantity is the independent variable and which is the dependent variable. So a couple more vocabulary words for you. The independent variable is the input variable, and it doesn't depend on another quantity. That's why it's called independent. It does its own thing. The dependent variable is the output variable, and its value depends on what you put in as an input value. So let's just take a look at some examples and try to determine whether or not these are dependent or independent variables. So example A says, in the winter, more electricity is used when the temperature goes down, and less is used when the temperature rises. So which thing is depending on another thing? So we're looking at the amount of electricity that's used and the temperature, right? So we can see that the amount of electricity is depending on the temperature. So electricity amount is the dependent variable, and the temperature would be the independent variable. Let's try letter B. The cost of shipping a package is based on its weight. Very practical, right? So which one's dependent on the other? Is the cost dependent on the weight, or is the weight dependent on the cost? Well, this one's pretty simple. The cost, the dependent variable, it depends on the weight of the package you're shipping. Letter C says, the faster you walk, the quicker you get home. So we have that the time that you get home depends on how fast you're going, your speed. So time is dependent upon your speed, the time you get home. Here is the function notation that you will need to get used to. So in algebra, x is always the independent variable. It's on the x-axis, that's called the independent variable. So when you're doing graphing, that's part of why you need to identify the dependent and independent variables so that you know how to graph it correctly. Y then is called the dependent variable. Remember, x is an input value, y is an output. So function notation, all that does is it changes, instead of y, we are going to use f of x, and that is exactly how it's read. It's f parenthesis x parenthesis, and we read this thing f of x. Okay? Now we can use any letter we want for function notation, but to begin with, we'll start with f for function. So what that says is the dependent variable is a function of the independent variable. So if we break down those words, the dependent variable, remember we said that is y, is a function of the independent variable, which is x. So breaking that down further, we can say y is in math means equals, f is a function, and then of x. Y equals f of x. So that is function notation. Rather than y equals x as an equation, function notation would say y equals f of x, right? Or f of x equals something else. There's several different ways to describe the variables of a function. So our independent variable, one of the ways we can say or describe that is call it an x value. We could also say that it's the domain. We could say that it's an input variable, or we could also say that it's just x. The dependent variable then would be y values. It would be the range. They could be outputs, or they could be y, or f of x, excuse me. So different ways of describing those two things. So if we're going to be writing functions, we want to identify the dependent and independent variables, and then we want to write a function rule using function notation. So if we have the lawyer's fee is $200 per hour for services, we have two things going on, right? We have the cost that we're going to pay the lawyer, the total cost. So we have cost, and we have time, right? So which one depends on the other? Does the time for services depend on the cost, or does the cost depend on the time? Well, cost is the dependent variable, right? That depends on how much time we need the lawyer to do our work. And the time is the independent, right? So I would just say the cost, the lawyer's fee, I would say, since that is the dependent variable, that is the output. So we could say f of c, the cost, is equal to, it's a function of the time, it's $200 for every hour times the number of hours, okay? Another way of saying that, if you just want to use regular function notation, you could say f of x is equal to 200 times x, where x is the number of hours. Okay, let's take a look at letter B. Admission to the carnival is $12. Each ride costs $1.50. Okay, well, what is the dependent and what is the independent? Well, the amount you're going to pay for the carnival, again, the cost, that's going to be the dependent, right? The cost depends on what? Well, it depends on how many rides you ride, right? So the number of rides would be our independent. So how could we write a function rule? We could say f of x is equal to $12 to start with, but then we're going to add $1.50 for every ride, and we're going to have to multiply that. So that would be our function rule. It's like y equals 12 plus 1.5x, but instead of y, we use f of x. All right, so this screen, we're going to talk about how we evaluate functions. Our directions say evaluate the function for the given input values. So if we have a function rule, f of x equals 5x, we want to find f of x when x is 6 and then when x is 7.5. So I'll start with x equals 6. So here's our function rule. We always start with that, but instead of x, we're going to substitute the number 6. So we're really finding f of 6, and f of 6 is 5 times 6, or 30. When x is 7.5, we just plug in 7.5. There's no math to do on the left-hand side. We're just writing the representation for what we're doing on the right. So we're multiplying 5 times 7.5, and that gives us 37.5. Here's another example for g of t. Our function rule is 2.30t plus 10. We want to find g of t when t is 2 and t is negative 5. Well, again, we're substituting 2 for the letter t, so just replace a 2 wherever you see the letter t. The left-hand side is just a representation. We don't have to mess with that. So we get 4.6 plus 10, which is 14.6. Over on the right, we're going to substitute negative 5 wherever we see the letter t. So that gives us negative 11.5 plus 10, which is negative 1.5. So that's how you evaluate a function. In the real world, sometimes real numbers are not reasonable for the domain or the range. So you might think about time. We can never have negative time or negative distance. And so it makes sense to only use whole numbers to represent things. So here's an example of that. So suppose Steve has a $50 gift card to Amazon, and he wants to buy some DVDs, and each DVD is $15. Write a function to describe the situation, find a reasonable domain and range for the function. Well, he's got $50 and each DVD is $15. So we would say f of x is equal to 15 times x, where x is the number of DVDs, right? Well, the output, the most he can spend is $50, right? So we have 50 is equal to 15x. And so solving for x, we would divide both sides by 15, and we get 3.3 repeating, 3 1/3. Well, we can't buy part of a DVD, so the most number of DVDs he could buy would be 3. So a reasonable domain, he could buy none of them if he could decide not to spend it, or he could buy 1, 2, or 3, 0, 1, 2, or 3. Now, if he doesn't buy any DVDs, the output would be 0. If he bought 1 DVD, the output would be 15. If he buys 2, your output is 30, and if he buys 3, the output is 45. So that is our range. Now this would be an example, just to go a little bit further, and what we talked about in our last video, this would be a discrete graph, right? It would be distinct points. It would not be a connected line. It would just be 4 points on a graph. So that is it for this video. We'll see you in class.